children, how are you? Welcome back to Language of Chemistry. Do you remember what we were learning in the previous class? We studied how to balance a chemical equation. Today, we'll see more equations and learn how to balance them. Before we begin today's class, I would like to tell you a very simple thing. I came to know that many children are finding it difficult to remember the radicals, their representations, their valency, atomic numbers, mass numbers, etc. And dear children, please do remember that these are the basics of chemistry. So you have to be thorough with all these. So the only thing that you have to do is just take an A4 sheet paper or a chart paper and write all these radicals and their representations in bold letters using colored pens, or you can use marker pens and just paste it in your study room. Make sure that you go through it every day at least once so that you can revise it, and these radicals and their representations with valency will be thorough for you. Once if you are thorough with all these representations of radicals and their valency, easily you can learn chemistry. Okay, I hope all my children will do this. So shall we learn how to balance equations? Today we'll see more equations and balance them. In the previous class we have seen two equations. That is, we learned how to balance an equation where water is formed. Hydrogen reacts with oxygen, giving you water. And today we are going to see another chemical equation, that is, hydrogen combines with chlorine. Hydrogen combines with chlorine, giving you hydrogen chloride. This is a skeletal equation. And you can see all the reactants which are present on the left hand side. They are combining together, or there is a rearrangement of atoms present on the reactant side. As a result, you get products on the right hand side. Okay, so here we have hydrogen and chlorine as the reactants on the reactant side, on the left hand side, and on the product side we can see that they combine together to form hydrogen chloride. This is just a skeletal equation. Let us see how many atoms of hydrogen and chlorine are present on left hand side and right hand side of this equation. Okay, so first let us write hydrogen. There are two atoms. Chlorine, again two atoms. What about hydrogen on this side? There is only one atom, and chlorine also you find only one. So now what is the next step, my dear children? You have to see how many atoms of which element is less and on which side is it less. So you can see on the left hand side there are two hydrogen atoms and two chlorine atoms. On the right hand side you have only one hydrogen and one chlorine. So what can you do? You have to increase the number of hydrogen atoms and chlorine atoms on the right hand side. For that, what can be done? You can multiply right hand side using the number 2, isn't it? Because on this side there are two atoms of hydrogen, and on this side again you have only one atom of hydrogen. Here you have two atoms of chlorine, only one atom of chlorine. So anyway, the number of hydrogen atoms and chlorine atoms should be increased by one more on right hand side. So what can you do? Multiply right hand side with 2. Now let us see. On the left hand side there is no change. On right hand side what happened? Hydrogen atoms became 2 and chlorine atoms are also 2 in number. Okay, so now hydrogen atoms 2, chlorine atoms 2 on left hand side. On the right hand side also you can see number of hydrogen atoms and chlorine atoms are the same. Now the equation is balanced. So I told you that once when you complete balancing, you have to rewrite the equation with the balanced numbers. Okay, so H2 plus Cl2 gives 2HCl. This is a balanced chemical equation for the formation of hydrogen chloride from hydrogen and chlorine. It's very simple and easy, isn't it? Now let us try how to balance the next equation. Here we have nitrogen combining with hydrogen, giving you ammonia. Okay, nitrogen combines with hydrogen, giving you ammonia. Let us try to balance this equation. What can you do, children? First, see the number of atoms of each element on the left hand side and compare it with the number of atoms of those elements on the right hand side. Nitrogen, 2 atoms, and hydrogen, again 2 atoms. On the right hand side, nitrogen atoms, just 1, and hydrogen atoms are 3 in number. So now, what can you do? Let us see first nitrogen, the first element. There are 2 atoms of nitrogen and only 1 atom of nitrogen on the other side. Okay, what is balancing an equation? When you balance a chemical equation, the first equation that you have written right here is just a skeletal equation which is not satisfying the law of conservation of mass or law of conservation of matter. So it's because of that we try to balance the number of atoms of each element on either side. So here what can you do? Nitrogen atoms are more on left hand side, okay, while hydrogen atoms are more on right hand side. So what can you do? So it's always good to balance the first element. Let's try to balance the first element here. It is nitrogen. 2 and 1. Anyway, there should be 2 nitrogen atoms here. So what can you do, children? You cannot write a number 2 here because it's a big mistake. Now, what is the other method? The only method is to multiply this compound as a whole with the number 2. Okay, so you multiply this compound NH3 with 2. Now let us try to write the changes that has happened in the number of atoms in a molecule of ammonia. Nitrogen atoms are now 2. Hydrogen atoms, 2 into 3. How many hydrogen atoms are there? Total 6 hydrogen atoms. But see the number of nitrogen atoms and hydrogen atoms on this side. It is nitrogen number is now equalized. 2 nitrogen atoms and 2 nitrogen atoms. And what about hydrogen atoms? Here you have 2, but on this side there are 6. So you have to make the number of hydrogen atoms on left hand side equal to 6. So what can you do? Here there are 2, that means 2 atoms of hydrogen. You have to make it as 6 atoms. So what is the only method? Just multiply hydrogen with the number 3. So 3 into 2 gives you 6. So what can be done, children? Either you can do another thing. Just rewrite this equation. N2 plus 3 into H2 gives you 2 NH3. Have you followed? So now what happens? Let us try to write the number of hydrogen atoms and nitrogen atoms. Now that is present in the equation. Okay, so nitrogen atoms are just 2. Now what about hydrogen atoms? Hydrogen atoms are now 3 into 2, 6. On this side, nitrogen atoms 2 and hydrogen atoms 2 into 3, it is 6. Just see, children, number of hydrogen atoms and nitrogen atoms are equal on both sides. The equation is said to be balanced. So let's try to write the balanced equation now. N2 plus 3H2 gives 2 NH3. Have you followed? So now the equation is said to be balanced. Okay, so now we shall see a few more equations. Just listen carefully, and you can also try balancing equations yourself and understand that it is very easy and simple. It's just a very simple method to equalize the number of atoms of each element on both sides. Okay, now we will try balancing a few equations which are given in page number 69 under the title In-Text Questions. Okay, the second question. Na plus Cl2 gives NaCl. Here, sodium combines with chlorine, giving you sodium chloride. Sodium is a monoatomic element. That is why it is written as Na. Okay, one molecule of sodium consists of only one atom. But chlorine is a diatomic element. One molecule of chlorine consists of 2 atoms. Okay, and a molecule of sodium chloride is written as NaCl. Now let us try to balance the equation. We know sodium atoms on left hand side is just 1. Okay, for convenience, not to consume time and also to save the space, I'm just putting a comma in order to write all the reactants, all the number of atoms of each element present on the reactant side in a single line. Okay, fluorine atoms, there are 2. Now here, sodium atoms, 1. Fluorine atoms, still 1. Sodium atoms and chlorine atoms are both 1. Okay, so now what is the only thing that you have to do? Here sodium atoms are equal in number, but chlorine atoms, 2 chlorine atoms here, but only 1 fluorine atom here. Can you write 2 at the bottom of chlorine? No, it is not possible because formula of sodium chloride is not NaCl2, it is NaCl. So always when you balance a chemical equation, you cannot add any number as subscripts. You cannot write any number as subscripts. That means at the bottom, you cannot write any number. Okay, and you cannot write any number in between the elements of a particular compound. Have you followed? The only thing possible is to multiply that whole compound. If it is a compound, it as a whole should be multiplied with any particular number. Okay, so here 2 chlorine atoms on left hand side, only 1 chlorine atom on the right hand side. So you can multiply this compound as a whole with the number 2. Okay, so now let us see what change. Only here we have done a slight change. So let us try to write the number of atoms of each element on right hand side. Sodium atoms are now 2. Chlorine atoms are also 2. Okay, 2 into Na. So 2. 2 into chlorine atoms. So 2 chlorine atoms. And see on the left hand side it is still sodium 1, chlorine 2. So chlorine atoms are balanced. Number of chlorine atoms are equal. What about sodium atoms? Sodium atom, 1 sodium atom is more on right hand side than on the left hand side. So what can you do? What can you do, children? You can just multiply sodium with the number 2. Is it not possible? So you can do one thing. 2 into Na plus Cl2 gives 2 NaCl. You are just multiplying sodium with 2, and this 2 is meant only for sodium. Okay, so now let us write the number of atoms of sodium. 2. Sodium atoms are now 2. Fluorine atoms are also 2. On the left hand side, on the right hand side, what happened? Sodium atoms are 2. Chlorine atoms again 2. See, the number of atoms of all the elements are equal. Okay, so now let us rewrite this equation. 2Na plus Cl2 gives 2 NaCl. The equation is said to be balanced. Have you followed, children? This is very simple and easy. The only thing is to check the number of atoms of each element on either side. Okay, so now let us try another equation. Na plus O2. Na plus O2 gives Na2O. Na plus, this is a skeletal equation given to you. How can you balance this? The same thing. Number of sodium atoms, 1. Oxygen atoms, 2. Left hand side, we have written the number of atoms of sodium and oxygen. On the right hand side, sodium atoms are 2 in number and oxygen atoms only 1. So, let us check. Sodium atoms are less on this side compared to this side, and oxygen atoms are more here and less on the other side. So what can you do? You can start from any side because on both sides you find one element less in number. Okay, so let us start from this side itself. Sodium. How many atoms of sodium? Only 1 atom, and here there are 2 atoms. So what can you do? Multiply the sodium with 2. Okay, so now let us write number of sodium atoms are 2. Oxygen atoms are also 2. Okay, and on this side, sodium atoms are 2, equal number. But see, oxygen atoms, we did not do anything on this right hand side, isn't it? Oxygen atoms are still 1. So you have to make it as 2 because here you have 2 oxygen atoms. So what can you do? Multiply this side with 2. Multiply this side with 2. So what can you do, children? Let us multiply this side also with 2. Okay. Or else you can do one thing, just write the number of atoms of sodium again, and then in the next step you can show multiplication. See, once if you are thorough with this method, you can do mental calculations. It's very simple to do mental calculations. I'm showing you all these steps because you are beginners in balancing this equation. So it would be good if you are writing these steps. But even if these steps are not shown, there is no problem. Equation should be balanced. That's all. Okay. So let us see. We have to multiply this side with 2. So Na2. Oh, this compound as a whole is multiplied with 2 because oxygen atoms are less. Isn't it? So now let us check. Sodium atoms became 2. Oxygen atoms are also 2. And what about this side? Sodium atoms, 2 into 2 became 4. And what about oxygen atoms? Oxygen atoms number is 2 because 2 into 1 oxygen, so it became just 2. Okay, but now what is the problem? Oxygen atoms are satisfied, but sodium atoms are less on this side and more on that side. So again, the next step, what can you do, children? Multiply this sodium again with 2. Follow? So 2 into 2 becomes 4. Okay, so now I shall write the equation at the top. 4Na plus O2 gives 2Na2O. 4 atoms of sodium, 2 into 2, 4 atoms of sodium. 2 atoms of oxygen, 2 into 1. 2 atoms of oxygen. The equation is balanced. I hope you understood how to balance the chemical equation. Okay, children? Now let us see the next equation. Let us see how to balance this equation. Iron is reacting with water, giving you an oxide of iron along with hydrogen. Okay, so iron plus water gives you triferric tetroxide along with hydrogen. Let us try to write the number of atoms of each element on the left hand side and right hand side. That also is written here. Iron atoms, just 1. Hydrogen atoms, 2. Oxygen atoms, 1. Okay, that's what I've written on the left hand side. And let us write the number of atoms of each element on the right hand side. Iron atoms, 3. Oxygen atoms, 4. And hydrogen atoms, 2. Okay, so this is what I've written. Now, let us check the number of atoms of each element on left hand side and right hand side. On left hand side, you have only 1 iron atom, while on right hand side, there are 3 atoms of iron. Okay, and in the case of hydrogen, the number is the same on both sides. And here, oxygen atom is 1 on left hand side and 4 on the right hand side. So let us begin with atoms of iron. Okay, on left hand side you have only 1 atom of iron, on right hand side 3. So anyway, you have to make the number of atoms of iron on left hand side 3. So what can you do? You can just multiply iron with the number 3. Okay, so now let us try to write this equation. 3Fe plus H2O gives you Fe3O4 plus H2. Now let us try writing the number of atoms of each element. Again, iron atoms are now 3, hydrogen atoms 2, and oxygen atoms 1. What about on right hand side? Iron atoms 3, oxygen atoms 4, and hydrogen atoms 2. Isn't it? I hope you understood. Now, number of atoms of iron are equalized on both sides. And hydrogen atoms are also same, 2 and 2. What about oxygen atom? There is only 1 oxygen atom on left hand side and 4 oxygen atoms on right hand side. So you have to equalize the number of oxygen atoms next. Okay, so where do you find oxygen in this? On reactant side, where do you find oxygen? In this compound, isn't it? In the molecule of water. So you cannot write simply 4 under oxygen atom. Okay, and it is not possible to write 4 in between H2 and O. In between those elements, you cannot write 4. So what is the only possibility? To write 4 on this side. Okay, for the molecule of water as a whole, you have to give 4, or you have to multiply H2O with 4. So that oxygen atoms will become 4 in number. So let us try that. 3Fe plus 4 into H2O gives you Fe3O4 plus H2. Okay, now let us write the number of atoms of each element. Iron 3, hydrogen becomes 4 into 2, 8. Oxygen atoms are now 4 into 1, 4. Let us check the number of atoms of each element on right hand side. Iron atoms are 3, oxygen atoms are 4, and hydrogen atoms are just 2. Check, children. Iron atoms are equalized on both sides. Hydrogen atoms are not equalized, while oxygen atoms are equalized. So we have to correct the number of hydrogen atoms on both sides. So on this side, hydrogen atoms are less. 2 hydrogen atoms are only there. But here there are 8. So how can you make this side 8 hydrogen atoms? Multiply this hydrogen with 4. So that you will be getting 8 hydrogen atoms on right hand side. Isn't it? So just multiply this equation here. Not this equation as a whole, but only for hydrogen. You are multiplying it with 4. Okay. So now let us rewrite this equation. After multiplying, 3Fe plus 4H2O gives Fe3O4 plus 4H2. Okay, now let us check the number of atoms of each element on both sides. 3Fe, 3Fe. 8 hydrogen atoms, 4 into 2, 8 hydrogen atoms. 4 oxygen atoms, here also 4 oxygen atoms. Now the equation is balanced. Okay, I hope you have understood how to balance a chemical equation. Okay, now let us see how to balance this chemical equation. Here you can see the reaction of sodium with water. Sodium reacts very vigorously with water, giving you sodium hydroxide and hydrogen. Okay, I have already written the number of atoms of each element present on the left hand side, that is on the reactant side, as well as on the product side. Okay, so once when you compare the number of atoms of each element, you can see that number of sodium atoms are same on both sides, and that of oxygen atoms are also same on both sides. But hydrogen atoms, here you can see only 2 hydrogen atoms on the left hand side, 3 hydrogen atoms on the right hand side. So how can you start balancing? You have to start balancing with that particular compound which consists of hydrogen atoms, and you must start with left hand side because number of atoms of hydrogen are less on left hand side. Have you followed, children? So how will you start balancing this equation? First, let us try balancing this equation by multiplying this compound consisting of hydrogen, okay, with 2. After multiplication, let us try to write the equation. It is Na plus 2H2O gives NaOH plus H2. Okay, now let us try writing the number of atoms of each element. Sodium 1, hydrogen 2 into 2 is now 4, and oxygen atoms became 2 into 1, 2. And on the right hand side, let us write the number of hydrogen atoms and oxygen atoms, and also sodium atoms. Sodium atom is just 1, hydrogen atoms are 3, and oxygen atoms again 1. There is no change on the right hand side because we didn't multiply, we didn't do anything on the right hand side. Okay, now let us check. Sodium atoms are the same. Hydrogen atoms are more now on left hand side. Oxygen atoms are also more on the left hand side. Okay, while hydrogen and oxygen atoms are both less on right side. So we have to select that particular compound which consists of both hydrogen and oxygen. Have you followed? Because we can see that both hydrogen atoms and oxygen atoms are less in number on right hand side. So if you simply multiply this hydrogen with any particular number in order to balance this equation, there again comes a problem because number of oxygen atoms are also to be balanced. Okay, so you have to select in this case a compound consisting of both hydrogen as well as oxygen so that it will help you to balance this equation easily. Okay, so now Let us try to multiply which compound consists of both hydrogen and oxygen, sodium hydroxide. So let us multiply this compound with 2. Okay, after multiplication, let's rewrite this equation. It is Na plus 2H2O gives 2NaOH plus H2. Let us try writing the number of atoms of sodium, hydrogen and oxygen on both sides. Sodium atoms 1, hydrogen atoms are 4, oxygen atoms are 2. Now on the right hand side, sodium atoms became 2. Okay, and hydrogen atoms 2 into 1, 2, again 2, so total 4. What about oxygen atoms? Oxygen atoms are now 2 into 1 oxygen atom, so 2. Okay, so now hydrogen atoms 4 on both sides, oxygen atoms 2 on both sides. Okay, but the problem you can see is with sodium atoms. Here you have 2 sodium atoms and here you have only 1 sodium atom. So you have to increase the number of sodium atoms on the left hand side, and you can see here on the reactant side there is 1 reactant sodium alone, isn't it? So you can multiply this sodium with 2. Now after multiplication, let us write the equation again. Rewrite 2Na plus 2H2O gives 2NaOH plus H2. Count the number of atoms of each element. 2 atoms of sodium on left hand side, 2 atoms of sodium on right hand side. 2 into 2, 4 atoms of hydrogen. 2 plus 2, 4 atoms of hydrogen. 2 atoms of oxygen, 2 atoms of oxygen. The equation is balanced. I hope by now you have understood how to balance a chemical equation. Okay, so children, try balancing all those chemical equations, skeletal equations that we have studied for different chemical reactions. Okay, you have to balance yourself and check whether you're getting equal number of atoms on both sides. Okay, now today we are going to wind up the class. Take care children. Bye-bye.